Welcome back to our series on rational functions. We are looking at horizontal asymptotes of graphs. Now, what does this look like? We've talked about vertical asymptotes of graphs. Now let's take a look at horizontal asymptotes. Now, our most basic rational function is 1 over x, y equals 1 over x, and it looks kind of like, ooh, that was a little messy, like this. Notice that there is a vertical asymptote at x equals 0, but the graph also approaches the line y equals 0. That is a horizontal asymptote, and at the ends of the graph, it's always going to approach that. We might even have a graph where there are two vertical asymptotes. That could be possible. So let's say we've got two vertical asymptotes here and here, and a horizontal asymptote at this point. So we've got my x and my y-axis and three different asymptotes. Well, what this might look like is like this. Okay. Notice that it still approaches that horizontal asymptote at the end. Now, once in a while, you will have times where the graph crosses a horizontal asymptote. Maybe it could look something like this. But at the ends of the graph, it will always still approach that horizontal asymptote. Now, how do we find these horizontal asymptotes? Well, we look at the degree of the numerator and the denominator. So let's take a look at three different possibilities for this. The first possibility would be that the degree of the numerator is less than the degree of the denominator. For instance, we could have something like y equals x squared plus 2 over x cubed plus 2x plus 3. Notice that the degree of the top is 2, the degree of the bottom is 3. And in this case, we always have the exact same horizontal asymptote, which is y equals 0. Just like in that last picture, that first graph I did, there was a horizontal asymptote at y equals 0. Okay? Another possibility would be that the degree of the numerator equals the degree of the denominator. So what if we had something like y equals 2x squared plus 6x over 4x squared plus 12x. Notice that we have a degree of 2 on the top and the bottom. The greatest degree of x is 2. Well, in this case, actually what we look at is the leading coefficients of those degrees. And my horizontal asymptote is going to be y equals 2/4, which we would reduce to 1/2. Our third possibility is that the degree of the numerator is greater than the degree of the denominator. An example of this would be y equals x cubed plus 3x minus 1 over x plus 2. So we have a degree of 3 on the top and a degree of 1 on the bottom. In this case, we actually do not have a horizontal asymptote. It would actually be an oblique asymptote or a slant asymptote, but we're not going to discuss those in this video. What you need to know is that there's no horizontal asymptote. Now, you may be saying, you didn't remind us to factor first, which is strange because you've been reminding us to do that in every video. Well, when we're talking about horizontal asymptotes, you actually do not necessarily have to factor first. But you probably will have already factored because you'll need to do that to find discontinuity, holes, vertical asymptotes. So let's take a look at what this would look like if the rational function is already factored. First one let's look at is y equals 2 times x minus 3 over 3 times 2x plus 15. Well, what we're really looking for is how many x's do we have? If we multiplied this together, what would be the degree of the numerator? Well, we only have one x right there, and on the bottom we only have one x. So which category would this fit? The degrees are the same. And what do? Well, we need the ratio of the leading coefficients, but we kind of have to multiply it together to get that. But really all we need is the highest degree. So what would I get as my leading coefficient of x? Well, I would get 2x. And we don't really need to worry about the rest of it. And on the bottom, 3 times 2x, I would get 6x and some other stuff. So what's the ratio of the leading coefficients? The horizontal asymptote would be y equals 2/6, which reduces to 1/3. How about this one? Y equals x minus 1 times x minus 2 over 2x plus 1 times x minus 2 times x plus 1. What is the degree of the top? Well, you notice we have two x's. The degree of the top is x squared. And on the bottom we have 3 x's. The degree of the bottom is x cubed. So, which category does this fit? Well, the denominator is greater. And what is always our horizontal asymptote when the denominator is greater? It's always y equals 0. One more. We have y equals 3x squared times x minus 5 over 4 times x minus 5. All right, what's the degree of the top? We have an x cubed, an x squared, and an x. That's going to turn into an x cubed. In fact, a 3x cubed. And on the bottom, we're going to have a 4x something. So the degree of the top is greater, therefore we have no horizontal asymptote. Let's go ahead and do a little bit of review. When does a horizontal asymptote occur? Well, it occurs when the degree of the numerator is less than or equal to the degree of the denominator.